This is Python and Deep Learning ICP-6 assignment. In this assignment, we have to review regression techniques, linear and multiple linear regression, and the clustering technique, k-means, and principal component analysis. For the first question, I have used house prices dataset, and we need to delete all the outliers for the data for the garage area field and plot the scatter plot between garage area and the sale price. And then we need to evaluate the model using all these metrics, and then use a simple linear regression and select one feature from all the columns which is positive correlated with the target column, which is the sale price, and create a regression model and plot the regression line between two features. As you can see here, I have imported all the required libraries and imported the dataset using pandas and checked for the skewness in the target column. As you can see here, there is a skewness in the target column, so we need to use the log transformation function from NumPy so that the mean is 0 and standard deviation is 1 for the target column to reduce the skewness in the target column. And then here I have printed the most correlated and the least correlated features in the dataset. As you can see here, overall quality is the most correlated, and these are 5 features in the dataset which are least correlated. And then here I have plotted a pivot, and then we can notice that the median sale price strictly increases as overall quality increases, as you can see here. So we can say that the overall quality is very important and most correlated features of sale price, and we need to retain this feature in our dataset. And then here I have calculated all the null values and then handle the missing values as shown here. As you can see here, we have most of the missing values. As you can see here, 1453 missing values from this column, which is very more. And then after handling the missing dataset, I have printed if there are any null values in the dataset. So as you can see here, there are no null values after the pre-processing and handling the so I have handled the missing values over here. And then coming to the next question, we need to plot the garage area versus sale price in the scatter plot and check for the anomalies and delete the outliers. So here I have imported all the libraries and imported the required dataset and then plotted the scatter plot. And then here I have visualized the dataset and I have seen the outliers, and I have defined these values in upper and lower variables, and then I have removed these outliers from the dataset and then plotted, and I have again plotted the scatter plot. And here is a scatter plot between garage area and the sale price with the anomalies. As you can see here, we can find the anomalies over the left side and the right side. So after removing the anomalies, here is the scatter plot. As you can see here, we don't have these points and these points, which are anomalies in the scatter plot shown above. And then here we need to evaluate the model using these 4 metrics and use a simple linear regression and select the one feature which is positive correlated feature with sale price and create a regression model and plot the regression line between two features. Here I have imported all the required libraries and imported the dataset using pandas and then handled the missing data. And then here I have split the dataset into training set and test set, and I have dropped sale price and ID column. And then I have used log transformation from NumPy on the target column so that there is no skewness in it. And then here, as you can see, I have used linear regression model on X-train and Y-train and printed all the metrics over here. And then here I have visualized the results using a scatter plot, and then I have plotted the regression line in the graph. As you can see here, here are the 4 metrics, and then here is a scatter plot with the regression line plotted in it. And then coming to the next question, I have used the same libraries which I have used above, and then I have imported the dataset. As you can see here, as seen above, overall quality is positively correlated, and so that I have used the one feature, the overall quality over here, and then I have used just the target column for the y variable, and have split the training set and test set over here, our data into a training set and test set, and use the regression model. And then I have plotted a scatter plot between those two variables, and then I have also plotted the linear regression line over here, as you can see, between these two variables. As these two variables are mostly positively correlated, as you can see here, after seeing the graph, after seeing the data points in the graph, we can see that they are correlated, positively correlated with each other. And then for the questions 2 and 3, we have to use restaurant revenue prediction, and then create a multiple linear regression for this. And then we also need to find the top 5 most correlated features to the targeted revenue column, and then build a model on top of these 5 features and evaluate all the metrics. So here I have just checked the correlation between each and every variable, and then here I have sorted the correlation with respect to the sale price, just to check the features which are most correlated. So here is a simple linear regression. As you can see here, as you can see here, I have imported all the required libraries and imported restaurant revenue dataset into restaurant values, and then I have dropped P2 city group and type columns, and then I have used on target column to store it in the y variable, and I have used test time split, and then split the dataset into testing and training dataset, and use the multiple linear regression over here, and calculated all the metrics over here, as you can see. And here are the scores. Here is the R-square score, RMSE, MAE, and MSE score. And then here I need to find 5 most correlated features, and then build a regression model based on it. So here I have found the 5 most correlated features over here. As you can see here, the 5 most correlated features are, here are the 5 most correlated features: P2, P28, P6, P21, and P11 columns. So using these 5 top most correlated features, I have trained the regression model, multiple linear regression model, and then I have calculated again all the 4 metrics over here and printed those values over here. As you can see, if we compare these metrics after considering only the 5 top most correlated features in our dataset, the values has reduced. Some of the values has the R-square value has reduced, and then all the other metrics have been increased. And here, as you can see, I have imported the required libraries as shown above, and then here I have used only one variable, which is positively correlated with the dataset, and have plotted, and I have used multiple linear regression and trained the model on the dataset, and I have predicted and I have calculated the required metrics over here. So here, as you can see, I have used only P2 column, which is most positively correlated. As you can see here, the P2 column, which is more positively correlated, and here are the metrics. And then over here I have imported the required libraries, and then I have found out top 5 correlated features to the target variable. As you can see here, these are the top 5 correlated features with the target variable. So I have used only these top 5 correlated features, and then trained the model on the training and the testing dataset, and again I have calculated the required metrics. So as you can see here, the R2 score is reduced a lot, because the number of columns which I have used has reduced drastically. This might be one of the reason for the reduction in the R2 score, R square value, reduction in the R square value. And then coming to the clustering part, here we need to apply k-means clustering to credit card dataset, and then pre-process the dataset and use the elbow method to find a good number of clusters with k-means and calculate the Silhouette score for the above cluster. And then we also need to try feature scaling and apply k-means on the scaled features and see if the Silhouette score increases with that after applying the standard scaling technique. As you can see here, I have imported the required libraries, imported the data, checked the shape of the data, and I have created the list of the features, and then I have dropped the ID column which is not in use, and I have checked the data set where there are more null values. So we can see that the most of the null values, here we have number of the category features with the null values are only 2, which is the minimum payments and the credit limit columns, and number of the categorical variables with null values are 0. So I have calculated the percentage of missing data with respect to minimum payments and credit limit. As you can see here, the null values in the minimum payments is very high, so it's better to drop it. And then the credit limit has very less null values when compared to the credit limit, so we can retain this column. As you can see here, calculating the number of number of null values, here as you can see, the minimum payments column has the more null values and credit limit has very less null values. And then here I have used elbow method. As you can see here, I have used the elbow method to find the good number of clusters with the k-means algorithm. So here is the elbow method showing the optimal k value, and after finding the elbow method, I can see that the number of clusters can be used here are 3. 3 might be the optimum value over here. So I have used number of clusters as 3. As you can see here, I have imported all the required libraries, And I have also find out the Davis Bodlin score also with Silhouette score, and the metric I have used in Silhouette score is Euclidean. So as you can see here, I have printed the both of the scores over here after training the dataset on k-means clustering algorithm. And coming to the next question, we need to use the standard scaler. As you can see here, I have used standard scaler and imported the standard scaler from sklearn preprocessing. And then again, I have calculated the Davis and Silhouette score over here. As you can see here, after standard scaling, there is slight improvement in Silhouette score. And then for the next question, we need to visualize the clustering and then apply PCA on the same dataset and apply k-means algorithm on PCA result, and we need to report our observation if the Silhouette score improved or not. Here I have imported the required libraries and I have imported the PCA from sklearn decomposition, and then I have used two components for PCA as a parameter, and then here I have calculated the Silhouette score for k-means with PCA and Silhouette score for k-means PCA and with the standard scaling. As you can see, after using the standard scaling on the dataset on the two principal components, there is a slight improvement in Silhouette score. And for this, for the below part, I have used the reference over here, and then here I have calculated the percentage variance of the columns and with respect to the principal components. As you can see here, for the first component and second component, much of the variance is present, and then as we go below, the variance reduces gradually. As you can see here, the first component has the much of the variance in it. So I have considered two principal components, and then I have plotted the clustering using scatter plot between the two PCA components, and then here I have used the k-means, and then I have plotted the clustering between the two PCA components as shown here. Thank you.